Let's look at some examples of problems you might solve using the distance formula. First example, if x is 3, 6 and y is 8, -2, find xy. So we've got 2 points and we're trying to find the distance of the line segment between them. Now remember the distance formula, we can do this, is the square root of x1 minus x2 squared plus y1 minus y2 squared. That's the formula to find the distance between 2 points. So let's think about what represents what in this problem, right? Okay, so d, the distance is xy, right? That's what we're trying to find, that line segment. Okay, x1 is one of my x values. You could say that it's 3, or you could say that it's 8. Now, if you're thinking, does it matter which one I choose? I would say try switching them around and see what happens, right? Go explore it on your own. That's the beautiful thing about math, is that you can test it and see what works and what doesn't. So if you've got that question rattling around in your brain, I would challenge you to test that out and see if you get a different answer. But for now, we're going to say that x1 is our first x value, 3, and x2 is our second x value, 8. Okay, so that's 3 minus 8 squared plus y1 and y2. Okay, again, that's y1 is the y that's with x1, so that's 6, and y2 is the y that's with x2, so that's -2. 6 minus -2. Okay, then. So yeah, let's go ahead and do a little bit of solving in here. 3 minus 8 is, 3 minus 8 is -5. 6 minus -2 is the same as 6 plus 2, or 8. Need to make sure we're squaring both of those. Okay, so then we have something that looks like this. The square root of -5 squared plus 8 squared. -5 squared is 25. 8 squared is 64. Let's try to stay consistent there. 64. So my answer is the square root of both of those, or xy is equal to the square root of 89. Now, normally I would say, wait, we're not done. We need to figure out what the square root of 89 simplifies to. However, for this problem, 89, no matter what you try to divide it by, you're always going to end up with a decimal, unless you divide it by 1 or 89. So that means my final answer, since 89 is prime, is that xy equals the square root of 89. Pretty straightforward. You take your 2 points, substitute them into the distance formula, and then find your distance. Let's look at a problem that's a little less straightforward. Use the distance formula to show that the following points are collinear. L at 0, -2, M at 3, 2, and N at 9, 10. All right, the word collinear, let's make sure we're all on the same page here. Collinear means that they're on the same line. Right? If 2 points are collinear, then they are on the same line. So looking at all my points, we've got L at 0, 0, x, negative 2y. M at 3, 2. And n at 9, 10. Let's see, 9. There. Are they collinear? If we draw a line, just a straight line through. Oops. We draw a straight line. Try my best here. Through. It really looks like these are all in the same line. But this is math, so I don't like just saying, well, it looks good, right? We don't want to say that it just looks good. We want to know that they're on the same line. So let's think about this. If the shortest distance between any 2 points is a straight line, then that means that the distance from L, the distance from L to M, if I add that distance to the distance M to N, that should equal the distance of L to N, right? And if that line isn't straight at all, if it's even a little bit crooked, then those two distances will not be equal to each other. So let's try it. We're going to use the distance formula 3 times. I want the distance for LM. I want the distance for MN. And I want the distance for LN. If I get those, if this distance plus this distance is equal to that distance, then we are good to go. So that's what we're trying to see. Does LM plus MN equal LN? Let's check it out. Okay, LM, that's the square root of x1, 0, minus x2, 3, squared, plus y1, negative 2, minus y2, 2, also squared. Okay, so that's the square root of negative 3 squared plus negative 4 squared, or the square root of 9 plus 16, which is the square root of 25, or 5. Okay, so LM is 5. Great. That's a great place to start. I guess we can say that. Okay, MN. Let's check out MN. MN is the square root of x1, 3, minus x2, 9, squared, plus y1, 2, minus y2, 10, squared. Okay, so that's the square root of negative 6 squared plus negative 8 squared, which is the square root of 36 plus 64, and that is the square root of 100, which is 10. Okay, so MN is 10. All right, so now let's just stop. What do we want LN to equal? What do we want LN to be equal to? Well, we want it to be equal to LM plus MN, which is 10 plus 5, or 15. So if the distance between L and N, between points L and N, is 15, then all 3 of these points are collinear. Okay, let's try it out. Ln is the square root of x1, 0, minus 9, plus y1 and y2, negative 2 minus 10 squared. Okay, so then that's the square root of negative 9 squared plus negative 12 squared. Negative 9 squared is 81. Negative 12 squared is 144. So that leaves 81 plus 144 is 225. Is the square root of 225 equal to 15? Well, you could check this out on a calculator. You could take the square root, or maybe you know your square roots, or you could simplify it. But if you take the square root of 225, you actually do get 15. So then, the following points, we know that they're collinear because the shorter distances added up and were equal to the longer distance. If they didn't add up, if it wasn't the same, then they would not be collinear. So that's two examples for you, one shorter, one longer, of ways that you can use the distance formula to solve different types of problems.